So dear participants, in our last lecture, we have got a concise idea of the registers in PLC. Let us now see what are the major registers available with PLCs. There are three major category of registers that is available for use. One is the holding register. This holding register is generically not available to the external user. Okay, then there are input registers which can be categorized further into single and group, and you have got output registers which are again categorized into single and group. Now you see that input and output registers are directly connected to the input terminals or output terminals. Therefore, these contents can be directly maneuverable from outside. Rather, I must say that the content of input registers can be maneuverable by outside, and whatever contents are there in the microprocessor out of some logical, arithmetic or control action, that decision in format of binary data is available to the output register, and finally the contents of the output register is available at the output terminal. So in that way we can say that the contents of these register are externally available or maneuverable. Now let us see that we would like to get a conceptual diagram that how these registers they are situated in the PLC. Now you see that these working or holding registers, the working or holding registers, they are large in number in comparison to the input or output registers. They are there at the central part of the PLC. So these working or holding registers are there within the central processing unit. Then there are the input registers and output registers, which are the external shields of the working or holding registers, and the input registers are finally connected to specific inputs, rather input terminals, and these output registers they are connected to specific output, rather output terminals. Now you can find that working on holding registers they are much higher in number in comparison to input or output registers, because whatever data or situation that the input register gets from the external world, that is sent to the holding register for further operation purpose. There can be some control operation, there can be some logical operation, there can be some data manipulation operation, like that. And once the operation is over, then the decision of the CPU, definitely in form of binary data, it is sent to the output register. This output register is finally connected to the output terminals, and accordingly the output devices can be manipulated with the help of the contents of the output register. Now you can see that registers are having certain nomenclature policy in PLCs. Whenever we are talking of holding registers, for example, we can talk of HR. HR means holding register. This is an alphanumeric technique. This HR shows the holding register, and this is the holding register number 256. Likewise, we can have an output register, and when we are talking of a group output register, we can say that O for output, G for group, and this is number 2. Now you see that functions of these registers and addresses, rather addresses of the registers, if you require particular address of the register for certain function that you want to develop, you need to definitely go through the operational manual of the PLC to know that which register is the output group register, which register is the input group register, which one are the holding registers, which one are the timing registers. That you should know very clearly. Otherwise, it will be hard for you to program the thing properly, or if especially you want to get some data from the external device inside the PLC, and then you want to manipulate that data through some processing action at the PLC end, and then you want to send the data to the output in form of another analog data. It will be very hard if you do not know where are the registers properly situated. That means what are the proper addresses of the register. So far these DI and DO operations are concerned, then addresses of PLC registers, they do not make much difference. But whenever we are talking of data manipulation actions, we are talking of data movement actions, we are talking of analog data input actions or analog data output actions, then knowing the addresses of PLC registers become very important. Now you see, let us concentrate on the holding registers that are available with PLCs. Definitely the holding registers, or they are many times being nomenclated as working registers, because actual work on the data, okay, they are taking place in these registers. Therefore they are either called holding registers or working registers. You see, these registers hold the contents of a calculation, arithmetic operation, logical operation or comparison operation whatsoever. So whenever such type of operation is there, then there should be some temporary storage space wherein the data has to be stored. Holding register is that area of temporary storage. Conceptually, as we have already seen, it is located in the middle of the CPU. And definitely if this holding register, it is not somehow connected to the external or the outside world, there is no goodness of this holding register. You see, these input and output registers, they are the interface of holding register to the external world. ये इनपुट और आउटपुट रजिस्टर जो है ये बाहरी दुनिया से होल्डिंग रजिस्टर को जोड़ता है. Now you see, typically, I am using the word typically because in some higher end PLCs, the contents of holding register can be directly accessible or maneuverable. Therefore, I am using the word typically. Typically, these holding registers are not directly accessible to input or output terminals. इसका मतलब क्या हुआ कि इनपुट और आउटपुट टर्मिनल जहां पे एक्चुअली आप डिवाइस को कनेक्ट करते हो विथ सम स्क्रू अरेंजमेंट, स्क्रू टर्मिनल्स जहां पे आप कनेक्ट करते हो, दीज terminals are not directly connected to the holding registers. Remember that whatever input data is there, you can see the signal data definitely they should be in the form of 0 and 1, that means binary format. From input terminal is deposited first in input register before they are sent to holding register. So this is very likely with any of the microprocessor or microcontroller that you cannot send the data directly to the heart of the CPU. Here we are talking of the holding registers. You need to first put them inside the input register, and then from input register the data will be going to the holding register. I hope that this idea is clear. Next, whenever some mathematical action or control action or logical action has taken place at the heart of the processor, that is the CPU, and then accordingly the result has to be sent to the output terminals, this is also not directly done. Whatever the contents of holding register are there which are ready to be output at the output end or at the user end, that are first sent to the output register, and then the contents of the output register is directly reflected to the output terminal. Then only the output devices can work with the contents of the holding register. So holding register is not typically available to the external world. They are available to the external world only through this input register or the output register. I hope that this concept is clear. So this is the illustration of holding register functions. As you can see here, this is one arithmetic operation. This is one arithmetic operation. You can see that data input is there. There is one enable input button. The enable input button works in such a manner that when this in normal open contact become connected, then the data input is valid. Now you can see there are two data on which we are to work. One is operand 1 and other is operand 2, and final one is the destination. You can find that operand 1, that is data input, whatever data 1 we can say, or this is data 2 we can say. This data 1 is going to this holding register whose address is 0075, and this particular data which we can call as data 2, that will be going to holding register 0076. And whenever the operation will be done, it can be any mathematical operation, then this destination, whatever the result is there, it will be located in this destination register, which is the having address holding register 0077. Now in this particular case, this is an addition operation, and therefore this is the output sum, and here is the overflow indicator. Overflow indicator is definitely part of any mathematical operation in any of the processors. In case of timer operation, you can see that there is one concept called preset. Preset means, preset is where the timing value is set. The timing value is set means, suppose we want to operate a timer for 14 seconds. So here you can find this 14 value has to be fed to the timer. Now where the timer will store this 14, this value whatever we are putting from our end or the user end, it is very easy. हम जस्ट क्या करते हैं, वहाँ पे एक ब्लैंक दिया रहता है, एक जगह दिया रहता है, क्योंकि पीएलसी बहुत आसान हो गया ना, आपको माइक्रो प्रोसेसर या कंट्रोलर जैसा झमेला नहीं करना पड़ता है. Already a block is there. Inside the block there is space to fill the time for which you want the timer to operate. वहाँ पे आप क्या करते हो, आप सिर्फ टाइम डाल देते हो. बट अंदर क्या हो रहा है वो जानने की कोशिश भी करना चाहिए. अंदर क्या हो रहा है कि there is a register given for the timer or allocated for the timer in which this preset value is stored. Now you can see register is the designated or holding designated register. You can see this register HR101, that means holding register 101 is the designated register in which the count takes place. इसके अंदर अपनी count हो रहा है. जैसे जैसे अपना count घटते जा रहा है, ये register की content धीरे धीरे घटते जाता है as per the time base whatever you see. ठीक है. अब यहाँ पे भी देखिए काउंटर ऑपरेशन में यहाँ पे आपने प्रीसेट करके रखे 21 मीन्स 21 काउंट होने के बाद आपका काउंटर आइदर अपने कॉन्टैक्ट को क्लोज करेगा या फिर ओपन करेगा, डिपेंड्स ऑन द टाइप ऑफ द काउंटर और द पर्टिकुलर कॉन्टैक्ट यू हैव टेकन एट द आउटपुट ऑफ द काउंटर. नाउ यू सी हियर द रजिस्टर or the holding register address is 102 where the preset value 021 is stored. So whenever the counter starts operating, then the contents of the holding register 102 is maneuvered during the operation. During the operation the counter counts down 21, 20, 19, 18. We can see that many PLCs they give you that facility to see that how your counts are getting incremented or decremented. You can see those numbers to be incremented or decremented, but actually those incrementation or decrementation is taking place in the holding register. Here in case for this particular example, the holding register is having address HR102. So this is the basic function of holding register. Now you see what are input registers. Very surely these input registers, they have got the same characteristics as holding registers. That means they are also 16-bit or 8-bit wide bitwise data capacity registers. However, the basic difference is that they are readily accessible to the input module's terminals or ports. ये बात तो जाहिर है, होल्डिंग रजिस्टर के ऊपर हमारी डायरेक्ट सुविधा नहीं था उसको रीच करने का, बट इन केस ऑफ इनपुट रजिस्टर वी हैव गॉट दैट डायरेक्ट एक्सेस. इनपुट मॉड्यूल के जो टर्मिनल होते हैं, दोज टर्मिनल्स आर डायरेक्टली कनेक्टेड टू द इनपुट रजिस्टर्स इन पीएलसी. नाउ यू सी नंबर ऑफ इनपुट रजिस्टर्स इन पीएलसी आर नॉर्मली 1/10 ऑफ दैट ऑफ होल्डिंग रजिस्टर. ये ध्यान में रखने की बात है कि इनपुट रजिस्टर की संख्या कम होता है और डेफिनेटली होल्डिंग रजिस्टर के 1/10 होता है. ऑल्दो दिस इज अ टिपिकल थंब रूल, इसका अलग भी हो सकता है. ठीक है. नाउ यू कैन सी इनपुट ग्रुप रजिस्टर इज अ स्पेशल कंसेप्ट. मैंने पहले बताया था इनपुट रजिस्टर दो किस्म के हो सकते हैं, एक है सिंगल और दूसरा है ग्रुप. Input group register is a very special concept. Here you see that each of the individual bits is directly accessible from one port, that is from consecutive input port terminal. You can see here the basic concept. Here you can see that there are two registers. This is one register and this is another register. You can see this is one complete terminal, right? There are terminal 1 to terminal 16. Terminal 1 to terminal 16. So this is a 16-bit terminal in which you can connect 16 different digital devices. I am talking of digital terminal only, DI, digital input. Now you can see that this terminal, complete 16 terminals, are internally connected to input group register 1. Here the speciality is each of the terminals are connected to each block of the input register IG001. I hope that this concept is clear. Here now this complete register is the input group register. Okay, now let us see what we were actually talking about. Here each of the individual bits is directly accessible from one input port that we have already seen. What is the advantage of this system? The advantage of this system is only one register is required to serve 16 inputs. Now you can see that here actually we are talking of one register. This register is 16-bit wide. That's an independent issue. That's a group. We should consider it as a group. But whenever we are talking of the register, it is one whole register. It is one whole register and therefore it is being called an group register. Now group register is having only one address. You are not independently addressing this register or this register or this register. You are talking of the complete 16 bits as a whole, as a group register. So this helps you in saving the space, memory space in your computational device. Now you can see in this case, when a port terminal is enabled, 1 is created in the corresponding bit slot, and when a port terminal is disabled, 0 is created in the corresponding bit slot. So that is very clear. If 1 is here, you can see that correspondingly the contents of that bit is 1, like that. Now you can see this is the input group or input port numbering scheme. This is an example thing. Here you can see that input group register number 1, for an 8-bit system it will control input terminals 1 to 8. For a 16-bit system it will have access to input terminals 1 to 16, like that. I don't think that now you should find it very hard to conceptualize the traits of output registers that are available with PLCs. They are having the same characteristic as holding registers. That means they are holding the data in bitwise manner. They can be either 8-bit wide or 16-bit wide. However, these output registers are readily accessible to the output modules, terminals or ports, and as we have seen with the input registers, the output registers can also be organized in a similar manner that of an input register. Here you can see that these are the 16-bit wide holding registers. So this is HR275, this is HR276, this is HR277. Now you can see the contents of HR276 is connected to this output group register 2. That means HR276 is connected to output group register 2 in such a manner that whatever is the data of this HR will be directly available with OG2, that means output group register 2. And finally the contents of output group register will be reflected onto the output terminal. So now you can see that this, whatever the contents of the holding register is, you are getting that content directly in the output terminal. However, without any direct connection in between the holding register and the output terminal. Definitely the via is output group register. So that's all about the contents of register. In our next lecture we will start with the concept of timer in PLCs. Thank you.